This is the example where we are going to work with the binomial series. Not all instructors introduce binomial series when they teach series expansions, Taylor series, Maclaurin series, because it's a little bit time consuming. That's why this video might be just some kind of extra example for your homework purposes or just to know something more. It looks complicated first, but actually it's not that bad. For topics like this, you need to know, or at least know how to find formula for the binomial expansion. So this is what we call binomial polynomials. Binomial series expansion has the formula first coefficient 1 plus this coefficient k times x. K is this exponent over here, just remember that. Plus, then you start accumulating terms with the next pattern. You have k, decrease k by 1, divide by the 2 factorial x raised to the second power. So 2 factorial x squared. Plus, next pattern will be k, and then k minus 1, and then k minus 2. So you see we keep accumulating the decrease. Divided by 3 factorial x cubed. Plus k, and then k minus 1, and then k minus 2, and you can guess it's going to be k minus 3 divided by what? 4 factorial x to the 4. And it's keep going. So you can always, I know you want to ask, do we need to know this formula for the exam? But I don't know, go ask your instructor. It really depends on the class and on the instructor. If I am your instructor, then you are screwed. Yes, you have to know this formula. Or not. Ask me at the moment when I teach. It depends on the class. It converges absolutely. Converges absolutely, which means converges with absolute values when x by absolute value is less than 1. So in our case, we need to use this formula I just wrote. And maybe I googled it, maybe I remembered it. It depends. Using this formula, we need to write down the expansion for a function 1 minus 5x raised to the minus 1/4, right? You can see it's the same thing. Same thing we were given. I just wrote it like so. It almost matches except we need plus and we have minus. But you probably already got used to the idea that we can use plus minus 5x raised to the negative 1/4. Now it works perfectly. I have 1 plus input raised to the k, and I have a given formula. My input is minus 5x, and my k is negative 1/4. So k is minus 1/4. Let's just immediately write down what we need using a formula in blue color for the binomial series. Let me write down actually because it has a name. Binomial series. So you see, you don't need to find any derivatives. Everything is already given. So from this point of view, it's kind of easy than other examples. You just need to know the formula or at least know how to find and how to use it. First 1, then plus k. K is negative 1/4. Not 1/4, negative quarter. Times x, but x is my input, so keep saying it out loud. Input is minus 5x. That's the first 2 terms already done. Plus k, k is negative 1/4, and then negative 1/4 minus 1 divided by 2 factorials. Input squared minus 5x, but now it is squared. Plus k times k minus 1 times k minus 2. So it's going to be minus 1/4 times minus 1/4 minus 1 times minus 1/4 minus 2 divided by 3 factorials. Input cubed, but input is minus 5x cubed. So always keep reminding you this is what we're doing. Some people call it u. U substitution kind of works here in your mind. It's different input than it used to be. Let's do one more just to make it more interesting. K, negative 1/4. K minus 1, negative 1/4 minus 1. K minus 2, negative 1/4 minus 2. k minus 3, negative 1/4 minus 3, divided by 4 factorials input minus 5x to the 4. It goes infinitely unless we want to have a finite polynomial, but I will make it infinite, like so. Now, let's simplify. How would you simplify? Well, now actually the tedious part starts. Take your calculator and a pencil and just multiply all of those numbers. So the first one will be 5/4, for example. This one, don't forget to square it first. So that's going to be 25. Then calculate what this is. Calculate this one separately. And then calculate this and multiply. So you just need to be very careful calculating all the coefficients. Let's the calculator helps you. That's going to be 1 plus 5/4 x plus 125 over 32x squared plus 1875 over 128x cubed plus 1875 over 2048x to the 4. Are you impressed? I'm doing it in my mind. Super impressive, right? This converges absolutely when absolute value of x less than 1, question mark? No. Remember that input was changed. New input is minus 5x. So minus 5x now should be less than 1. When you divide by the negative 5, well, inside of absolute value that doesn't matter, so you divide by just 5. It becomes x less than 1/5. That is my new convergence set, which has radius 1/5, center 0, right? Radius 1/5, center 0. Now, if you are asked to find first non-zero 5 coefficients, for example, your homework asks for that or not, so let's find first non-zero 5, or first 5 non-zero coefficients, right? That's probably a more proper way to say it. It's going to be c sub 0, c sub 1, c sub 2, c sub 3, c sub 4. Those are my 5 ones. How do you find these? Those are coefficients which you calculated separately. And now you can write them down. It's going to be 1, 5/4, 1 over 25 over 32, 1875 over 128. Who is faster? 1875 over 2048. I'm faster. Good. And that is the answer. That's all the needed information we were asked about this example. So the function was given. We found the formula for binomial series, so maybe you remembered. And then we just copied it and used, for example, we need. Then the tedious part is actually this equal sign to calculate all the coefficients. And then we can collect them in the table like so. And also don't forget to recalculate new convergence set. Convergence set, a new radius, but the same center of convergence. Thank you for watching, and don't be afraid of binomial series. They are pretty straightforward, to be honest. See you next time.